All right, so as you can see, number 15, and again, this is section 3.4, is talking about the following frequency table gives the age of each student taken from random sample of 50 high school calculus students. And you can see they're giving us the ages and then, of course, how many students are at that age, and they're asking us to find standard deviation. So let's take a look at this example here. So obviously I will be going to my very trusty Google Sheets. And I was actually talking to Maddie after our class ended last time, just getting a sense of what was the preference? Was it spreadsheets or doing it by calculator? And it just seemed like from Maddie's perspective that spreadsheets can be a little intimidating. So is that something you guys feel when you're working with spreadsheets? Is it like a scary thing to use spreadsheets? Just because, as we understood that it's not something high schools really teach you. So is it just an apprehension that it's a new technology and you're not sure how to use it, or is there some other reason?
I like spreadsheets.
I get married to spreadsheets. I
Okay,
use them for everything.
okay, so were you comfortable? Were you comfortable with spreadsheets, ladies? Before this class, like, had you used them before? Or did you learn spreadsheets like as we've been?
I've been learning them as we went, as we go.
Okay, so you didn't have like a prior experience per se? Okay, that's interesting, okay.
Spreadsheets too.
Had you been using them before you started in this class? No, so you also were okay accepting it? Okay,
I don't mind spreadsheets either.
okay, is it just this table then?
I usually like spreadsheets.
Okay,
Yeah.
Usually,
you usually like or dislike?
except for when for some reason they don't work.
Well, yeah, and I can understand that. Lily, I know where you stand on that. So Lily has been very open with me about her dislike, strong dislike, which is okay, not to, because if it's a thing about, if I can create some templates for you.
Oh, that would be awesome.
Okay.
Beautiful.
Well, that answers my question.
Please.
Because I didn't know that would be less scary if you had like, put this here, put that there, and then, it's kind of
So
designed for you, because I know one thing Maddie had also mentioned was when you like start typing a function name and it gives you like a list of 100 functions, and then you're like, oh, but which one am I supposed to use? And I think that can also sometimes get confusing. Okay, so we can work on some templates because that seems to be the consensus. All righty, we can do that. Would anybody on Zoom like to share their thoughts on spreadsheets? Do you guys have a preference or a strong dislike for spreadsheets? So you can put it in chat if you want, you can unmute and speak, whatever you're comfortable with. Because again, I keep joking that Google should be paying me for promoting their product. But I like spreadsheets because I feel like, if you're going through the formulas, that can be a longer process, one, to calculate. But also if you make a mistake, then it's almost like you have to start at the beginning and figure out where you went wrong. With the spreadsheets, it's what, 3 or 4 arguments that we put in. Strongly dislike. Okay, Crystal, thank you. So yeah, if it's just a matter of, but have had prior experience. Okay, Brooke, thank you for letting me know. So yeah, I can work on some generic templates and then you guys can kind of modify them as per your needs if you want, and I can give you a list of the functions that would come in handy. All right, guys, so let's look at this. Again, this is example number 15, talking about standard deviation for the ages of a random sample of 50 high school calculus students. So when we are talking about working with a frequency, okay, Miguel just sent a comment on spreadsheets. I like it because it's faster to copy into sheets than to type into a calculator. Yeah, definitely that would make it, again, very easy to, and that's one thing I would mention is a lot of times when we are copying something and writing down by hand, it would be easy to make a mistake in just copying a number, right? But if you're copying and pasting the numbers, then you know that, unless something really bad happens, you will get the correct numbers copied over. So yeah, that can also make it a simpler process. All right, guys, so how do we calculate a spreadsheet? And the reason this one is a little bit different is because you're given a frequency here, right? So we actually have to figure out how many students are actually at that age of, 15, 16, 17, 18. So we know 2 out of the 50 students, 2 of them are at age 15. One of the students is 16 years old. 29 of the students are 17 years old. And of course, 18 students are of the age 18. So if you were to calculate the mean for this, we would need to know what all the 50 ages are, right? We would add them and then divide by the total. So we're going to do the same thing, but instead of writing all 50 ages out, which would be a tedious process, obviously we'll use technology. So the first thing you want to do is go ahead and add up that total for the frequency column, because we want to make sure we do in fact have all 50 students here, right? So you can just use the sum function. So, and then add these 4 numbers, and you can see we do in fact have all 50 ages in there. Now, before you can calculate the standard deviation, we do need to know the mean. And you know what? Let me actually go into our textbook over here. Textbook. There. 3.4. So just to show you the arguments we need when we are calculating the standard deviation using the built-in function. Let's go past that. So you can see the built-in functions for standard deviation are either standard deviation dot S or standard deviation dot P. And the difference is dot S stands for if it's a sample that you're looking at, dot P would be if you're looking at the entire population. So of course, if you look at this one here, they're telling us this is a random sample of 50 high school students. Of course, we know we have to use the dot S, which is what we would normally do. But again, since this is a frequency distribution table, the only way you can use the dot S function would be if you list all 50 of those ages out. And like I said, that's going to be an even more tedious project. So what we are actually going to end up doing here is you're going to take your age value, which is the X column, and multiply it with the frequency column. So the first thing we're going to do is take, and you can see Google Sheets kind of automatically is like, oh, is this what you're trying to do? So yeah, I'm trying to take X value, which is the age of 15, and multiply by how many students were 15 years old. So you can see those 2 students together would add up to 30, right? 15 plus 15 would be 30. And then you can see it's the same thing. It's asking us to do an autofill here. We don't need that one. So you can see this one would be, okay, there's only 1 student who's 16 years old. So that total would be 16. There are 29 students who are 17 years old. So if you add that 29 times, it would add up to 493. And then you can see for the 18 times 18, of course, that's going to be a total of 324. So that's telling us basically if we take all the students and add their ages together, what that total would be. So I need to go ahead and add that column also. So you will see this total with all the ages is coming out to be 863. Now, even though they did not ask us to find the mean, I'll show you how to find the mean so that if you do have an example where they want to know what the mean is, you know how to calculate that. So we took our frequency, multiplied with the ages, the X value, we got that total. So now to find the mean, what you basically end up doing is you take the total of the X times frequency column and divided by the total of the frequency column. No, it's not a function. I know why it's doing that. I should take that equal to. Okay, so basically take the total of the X times frequency and divide it by the total of the frequency column itself. So that's of course going to be 863 divided by the 50. So that's how we would calculate the mean, because basically we've taken the total of all 50 of those ages divided by the number of students. So we can see an average age for the student. Are they just high school students or from a single class? I guess they're just high school students. So we're saying the average age of a high school student is going to be 17.26. Usually we don't have people chit-chatting in the hallway. Alrighty, guys, so now we have our mean. Now, how do we calculate the standard deviation? So this is where, remember how in our textbook, when we had first introduced standard deviation, we had to go through this process where you took the deviation, then the deviation squared and that kind of route. And then, of course, we did the sum of the squared of the deviations divided by n minus 1. So we would kind of have to use that same idea here. So we started out by doing x times the frequency. Now we are going to take no, so it's actually going to be the x minus the mean, sorry, can't spell. So in this case now, we will take the x column, the original x column, subtract each of those ages from the mean. So this one would be 15 minus the mean, and I'm going to leave that at 2 decimal places for now. I'm not going to do any rounding. Okay, and basically repeat the same thing for all the other ages. So we're going to take our age 16 minus the mean from that, 17 minus the mean. And of course, the last one was age 18 and subtract the mean from that. So you will see all the numbers that were smaller than our mean give us a negative answer, and all the numbers that are larger than the mean will give us a positive answer. So we took the X value, the individual ages, subtracted the mean from it. So this was basically that deviation that we're talking about. So kind of like this column we have, over here is what we've done here. We took the data value and subtracted the mean from it. The next thing you will do now, because we do have negative answers in there, you're going to take that column as X minus the mean, and we are going to square it. So you're going to take basically this number here and square it. So you can do, just click on the cell and you can do raised to the power of 2 if you wanted to square it. Or your other option would be, and I'll just show you that in the cell here. You can click on the cell that you're trying to square, do the multiplication and click on the cell again. So either do the caret raised to the power of 2, or you can just multiply the cell into each other. So whatever you're comfortable with. I'm just going with the exponent of 2 and then just copy that over to the remaining cells. So you can see we did D5 to the second power, D6 to the second power, D7 to the second power. So this is now our deviation square. So this is what we've done over here now. Okay. Now, again, since this is a frequency distribution, the next thing we are actually going to do is we are going to take the square values that we just calculated and multiply it with the frequency, because we still have all those students who are at this age. So we need to figure out how many students will fall under this. So you're going to take your deviation column, squared deviation, and multiply it with the original frequency column. Okay, so again, X minus mean, the whole quantity squared, you're taking that column and multiplying it by the original frequency for that category. And then, again, that's another good thing about Google is like, hey, I can do that for the rest of your cells. Do we want that? So again, just verify that everything was done correctly. So you've got 5.1076 multiplied by 2, 1.5876 times 1, so it stays the same. 0.0676 multiplied by 29, and then 0.5476 multiplied by 18. So now this is the total that we are interested in, because now we have figured out how far away from the mean each of the ages are. Now we know how many students would fall into that, so we've multiplied it with our frequency. So now you are going to take the total of that last column we just calculated, so the x minus mean squared times frequency. So this is now acting as that sum of the squared of the deviations from the mean. So we do have that in place. And then for the standard deviation, do I need to do anything else? We already have the total of our frequency column. So yeah, for standard deviation now, there we go. You are going to take this total of the 23.62, and we're going to divide it by, remember it's n minus 1. Again, you can see in the formula here, n minus 1. So our n is actually that total from the frequency column, so it's going to be 50 minus 1. Now you can type in 49 if you want in there. Since I'm doing the cell selection, I did 50, and then I'm typing in the minus 1. You will see I'm also putting that in parentheses, because we need to do the subtraction before we do the division. So by putting those parentheses, we're letting the calculator know grouping will go first. Again, please excuse my dear Aunt Sally, PEMDAS. So we'll do the subtraction first and then the division. So this is actually not your standard deviation yet. This is a variation because I haven't included the square root in there. So this will technically be variation, but as soon as I do a square root on this value of 0.48, because again, remember, you do have that square root you need to do on your standard deviation. And I did not have a square root in there, right? I've just got my totals and my division, right? So now I'm just going to use the square root function, which is SQRT on that number, 0.48. And when you take its square root, you can see it comes out to be 0.69. So we're saying on an average, students are 0.70 away from the mean, which is, 17.26. So we're basically saying the ages of the students are pretty close towards the mean. They're not spread out, because it would be kind of crazy if you had a 10-year-old in a high school, right? Can happen, does not normally happen. You wouldn't see like a 22-year-old in high school either, because those would be people more likely getting their GEDs, right? Instead of going back and finishing high school. So this kind of makes sense that your standard deviation should be small, because your high school students are going to be in that age group. We may see a 19-year-old, right? Because it may just be based on where their birthday falls, but we wouldn't be seeing a lot of younger or older people in there. So you should expect that standard deviation to be pretty small, and we are definitely noticing that. So they asked us to round this to 3 decimal places. So I'm actually going to just copy this over in a new cell. And then remember, you have this little keys at the top that help you decrease the decimal cell. So I'm just going to reduce this till we get down to 3 decimal places, and looks like that rounds down to 0.694. So let's try that. 0.694 and see what this guy has to say. All right, he looks good. Which I wonder if it would accept if you even put all the decimal places, because sometimes my OpenMath does that. It will accept all decimal places. So questions on calculating. So this one, of course, looks a little bit different. If they just give you 10 ages and you had to calculate, then you could, if you didn't want to use the spreadsheet, you could kind of follow the formatting that this example has. But when they give it to you as a frequency distribution table, and you can kind of see in this example, they had given us all the 36 dollar amounts, right, for students spending on textbook, but we would have to create that list for all 50 of the ages. And like I said, that would end up becoming a much, much more longer and tedious process. So I do not really recommend doing that. So using this idea of frequency would help you out better. Did that work out, Jessica?
I
Yeah.
need to know how to make it.
Get the, okay.
Yeah, thank you.
Very good. And then we also had a question on number 20. But again, before I move on to number 20, I wanted to see if anybody else had a question on 15. Anybody on Zoom had a question on number 15? No? Alrighty. So let's look at 20. So number 20 here, let's make him a little bit bigger. Can you guys see that? Yeah. Okay, so this is saying, scores on the SAT test have a mean of, 1,470 and a standard deviation of 290. Scores on the ACT have a test, ACT test have a mean of, 19.9 with a standard deviation of 4.9. So they're saying DeAndre took, both tests and wonders which is relatively better. So it looks like they had a score of 2,044 on the SAT and a score of 30. And of course, since you can see the scales are so different on the two exams, which one would be a better test score, like I guess on which they performed better. So I'm just gonna bring this example here. Can you see that? No? So this is a Z-score problem because they're basically asking us to compare two different scales on two different tests and see how that would work out. So let's do the SAT. So the mean on the SAT is 1470. Are you able to see that, Roberto, or am I like kind of blocking your way? A little bit, sorry, I didn't even realize that as we went through that whole example there. So mean is 1470, standard deviation is 290. And then DeAndre's score was on the SAT, what did they say, 2,044? Okay, and then for the ACT, the mean for the ACT is 19.9. The standard deviation is 4.9. And then let's see, DeAndre had 30. So remember, Z-score is defined as, the score or the data value, so X minus the mean. And you do have to do the subtraction first. Okay, so do the subtraction first and then divide that subtracted value by the standard deviation. So for the SAT, the Z-score again, parentheses, you want to take the score that the student had, so 2,044 minus the mean, so 1470. So you're taking those two numbers, subtracting first, and then divide that difference by your standard deviation. So it looks like the SAT score value is coming out to be 1.979. Now, by itself, it doesn't really tell us much, right? Because this is just saying you are just shy of 2 standard deviations away from the mean is just basically what they're saying. So I would actually say that's a great score for if you are about 2 standard deviations above the mean. Because you remember that's where by the, hey, it's snowing, finally, thank you. What? Yeah, see, you can
That's
see.
not good.
That is too good.
Unless it's pollen, but it looks like snow. So thank you. I do not feel so bad anymore. That we got inches and you guys got none. I know, I was having FOMO here, people.
That's an odd case of FOMO. I don't know why you would want it.
You're like revenge.
Because I had to drive through crud to get here.
Do
No,
you not like the snow?
not
Do you
driving
like
so much in
driving
it.
in the snow?
Not driving so much. And especially when you have cars in front of you with cakes of snow flying at
Flying
you.
at your face.
And so I do not, enjoy that part. All right, guys, so same calculation, right? For the ACT, you take 30 as the DeAndre score minus the mean, which is of course 19.9. So it's subtraction first, so put that in parentheses and then divide that by the standard deviation of 4.9. And look at that, they actually were above 2 standard deviations above the mean. So this is actually telling us that comparing now both of them, you can see the ACT was at 2.061. So DeAndre actually did slightly better on their ACT exam as compared to the SAT. But again, I think both of them are really good scores because you can see they're close enough to that 2 standard deviation mark for each of those categories. So that's how you would do the comparison. So let's see what the questions are now, since we have our calculations done. So they are saying DeAndre's score on SAT, are they just asking us to type in the score that they gave us? Doesn't it seem like that, 2044?
No, it says his Z score.
Oh, Z score, okay, I missed that part, I just read the score. So
I
the
thought so too for a second. I was like, all of that.
Z score, and what rounding did they tell us? 2 decimal places, so we do need to round this to 2 decimal places. So let's go ahead and round it down. So again, I'm just gonna use the decreased decimals to get that done, and I would imagine the same thing here. So let's round this down to 2 decimal places as well, which of course comes out to be 2.06. All right, so their SAT Z score was 1.98, so this should be 1.98, and their ACT was the 2.06. So 2.06, I'm just gonna submit that to make sure we're on the track here. And then they are asking us, since DeAndre's score, Z score on the SAT is less than, same, or greater than the ACT, what would we say? For Z score on SAT versus ACT. Is the SAT less than, greater than, or the same? Less than, right? Because it's 198 compared to the 2.06. So we would conclude that DeAndre did relatively better on the ACT. DeAndre did relatively the same on both exams. DeAndre did relatively better on SAT. So which one would be a better score, the ACT or the SAT? ACT, because that's the higher Z score. So let's check that. Does that make sense, Roberto? Yeah, of what comparison we need to do? And then the Z score calculation, of course, again, like I said, it's the mean being subtracted from your data value. And then divide by the standard deviation. All right, there you go. So data value minus the mean divided by standard deviation. Now, again, this calculation is simple. You can do on a calculator, but again, if you have a spreadsheet, you can use that as your, and you can do this separately also, guys, if you wanted to. So you could do the subtraction first. You could say, okay, 2044 minus 1470. So do the subtraction first, and then you can say, okay, now take that subtracted value and divide by your standard deviation, and you'd still get the same result. So you can break up that calculation in 2 different cells if you wanted to do that. So this was the X minus the mean, and then you took X minus the mean. And divided by standard deviation. So break it up if you wanted to do that. All right, everybody okay on 3.4? Did we have any other questions? All good? Yeah, okay. All right, guys, so let's get back here into our textbook. And we had just started talking about section 4.1. So we'll pick it up from there.